welcome to Radicals 3.3, nth root and rational exponent equations. All right, tonight we're gonna continue solving for x, and this is kind of a continuation from the Radicals 2.1, 2.2, 2.3 lessons where we solve for square roots, but this time we're gonna solve for radicals that are a little bit bigger, where sometimes it might be a cube root or a fourth root or a fifth root, etc. So the process you see is going to be very similar to what you saw in Radicals 2.1, 2.2, 2.3, and yeah, it's going to be very similar. Okay, so let's begin. Okay, so let's rewrite the problem so I can start to manipulate it. So cube root of 3x plus 2, and then plus 1, and then equals 0. Okay, so we're gonna subtract 1 on both sides, and this is going to allow us to, I guess, get the radical all by itself, the cube root radical all by itself, because once it's by itself, then we can get rid of that radical. Okay, so that's the key thing that you want to do first. You want to get rid of that number, that positive 1, so that you can isolate the radical, and once you isolate it, then you can use powers to make that cube root disappear. Okay? All right, so what do we got? We got cube root of 3x plus 2, and then equals negative 1. Okay, so we're gonna cube both sides, or you can think of it as, they call it exponentiate. Okay, so you're gonna put a power of 3 on both sides, and by doing that, you're gonna cancel out the cube root on the left side. So when this happens, all you're gonna have left is 3x plus 2. So that left side kind of should look familiar, because the same exact sequence happened when we did square roots, right? When it was a square root, we squared both sides, and the radical symbol disappeared. The square root symbol disappeared. So same concept here. Okay, so right side we're going to get negative 1, because negative 1 to the third power is negative 1, right? Negative 1 times negative 1 times negative 1 is negative 1. Okay, then we're just going to continue solving for x. We're just going to get the x by itself, so subtract 2 both sides. And let's page extend. So we get 3x on the left side equals negative 3. Then we're going to divide by 3 both sides. And we get x equals negative 1. Okay, so you want to check your answer. So let's check the answer, x equals negative 1. And let's see if it works. So plug it into your original problem. So cube root of 3x, so that's going to be 3 times negative 1, plus 2, and then plus 1 on the side, and equals 0. Okay, so when we check our answer, same exact process that we did earlier. Okay, we don't want to let the two sides interact, so I don't want to catch anybody subtracting 1 on both sides. I don't want to see anybody exponentiate both sides by doing a power of 3 on both sides. Do not do any of that kind of stuff. Okay, your right side already is simplified. It's a 0, so that's your target. So now you're just going to play around with the numbers on the left side and see if you can create a 0. And if you can, the negative 1 answer has been verified, and you can put it on the answer line. All right, so let's start playing with the numbers. So cube root of 3 times negative 1 is known as negative 3, plus 2, and then plus 1 on the outside. Okay, so you're going to get cube root of negative 1 plus 1. Okay, so now you're going to break apart the negative 1 into little pieces so that you can start circling things. So let's see what that negative 1 can be broken up into, because I got to look for 3 things that match. So I'm going to write 3 negative signs, and we kind of did this in the Radicals 3.2, 3.1 lesson. Okay, and then you got 1 times 1 times 1. Okay, so you're going to circle things that match. And this time we're looking for 3 things that match. So I think this is Radicals 3.1 if I remember correctly. Okay, I think I said 3.2 earlier, but it's 3.1. All right, so you circled negative, you circled the 1, and that's going to be what's going to jump outside. So negative 1 is going to jump outside. Oops, forget to write the positive one there. So negative 1 jumps outside. It joins the positive 1 that's already outside waiting for him. And this becomes a 0. So when you compare the left side to the right side, this should look familiar as well, this step. They match. And if they match, we're happy about that, because that means that my answer has been verified. So negative 1 is good to go. Okay? All right, so let's move on to the next problem. Number 2. Okay, so same process is going to happen. We're gonna do whatever it takes to isolate that radical. And once we isolate that radical, then we can exponentiate both sides with whatever number we need to use for our power. And we're going to get rid of that radical. So let's get this process going. So 3 on the outside, 4th root radical of 2x plus 6, and then minus 9 equals 3. Okay, so let's get rid of the things that are outside of the radical. So let's get rid of our 9 first. So add 9 both sides. And I think the last time we did problems just like this, a lot of you guys tried to divide by 3 first when I was looking at the homework. And you can do that, but when you guys are dividing by 3, you guys are making a mistake. So if you haven't fixed that issue that you guys are having when you tried to divide by 3 as your first step, then you might not want to try and do that right now. You might want to just follow what I'm doing. Just get rid of this plus or minus number first. Okay, so your right side number is 12. Oops, why isn't it writing? Okay, there we go. So 12 on the right side. The 9's cancel out, and you get 3 times the 4th root radical of 2x plus 6. And then we're going to get rid of the 3 next. And it's going to disappear pretty easily, right? Just going to divide both sides by 3. So you get 4th root radical of 2x plus 6 equals 4. Okay? Then you're finally ready to get rid of this 4th root radical. So you're going to exponentiate both sides. You're going to do power of 4 on both sides. And don't worry about knowing that term when I say exponentiate. When I just say exponentiate, that just means put a power on both sides, basically. Okay? So left side is going to turn into 2x plus 6. Oops, why is it purple? I thought I pushed blue. Okay, so left side is going to be 2x plus 6. And then 4 to the 4th power. I believe that is 256, if I did my math correctly. I think I did. Okay, page extend. Then let's continue solving for x. So subtract 6. And then we get left side is 2x. Right side is 250. Then I want to divide by 2. So divide by 2 both sides. And I get x equals, back to blue, x equals 125. Okay, so I hope this answer is correct, but the only way to be totally sure is to plug it in. So we're going to check the answer x equals 125 by plugging it into our original problem. And right now I can't actually see my original problem, so let me scroll back up a little so that I can see it. There it is. Okay, so make sure you plug it into your original problem. All right, so 3 on the outside, 4th root radical of 2x plus 6. So I'm not going to write the x. I'm going to write what I'm going to plug in there, which is 125. And then plus 6. Then minus 9 on the outside. And equals question mark 3. So we're trying to verify if the two sides are going to be equal. And if they are equal, then the answer works. Okay, so I got my target. My target is a 3. Okay, so I'm not going to do anything to the right side. And please, I said this in the last problem, don't make the two sides interact. Okay, so I don't want to catch anybody adding 9 to both sides. I don't want to catch anybody dividing by 3. Do not do all that kind of stuff. Just play with the numbers on the left side and see if it can become 3. Okay, so let's do our thing. So 3 times the 4th root radical of, and then 2 times 125 becomes 250. Then plus 6. And then minus 9 on the outside. Okay, so let's play with some more numbers, and we get 3 on the outside, 4th root radical of 256 minus 9. Okay, so now I got to break apart 256 into smaller numbers that hopefully I can find 4 things that match. And if I can find that, then I'm home free. Okay, and a lot of you guys are probably wondering, oh my goodness, I have to break apart 256 into smaller numbers. Well, just take a look at this. Okay, take a look at this real fast. When we did this step earlier, 4 to the 4th power. 4 to the 4th power became 256. So that kind of tells you how I'm going to break apart the 256 right now. Watch what I'm going to write. So I'm going to put 3 on the outside, 4th root radical of 256, which I'm going to break into smaller numbers, and I'm going to choose to break it into a bunch of 4s. So how many 4s am I talking about? Well, like I circled in purple on the left, 4 4s made 256. And coincidentally, that's how many 4s I'm looking for to be able to circle. Because if I can circle 4 4s, they can all go outside. Okay, so it came out nicely that it worked out that way. It's probably going to usually work out that way a lot, but yeah, in case you didn't notice that pattern, now you see it. Okay, so I'm going to circle the 4s, the 4 4s that match, and I'm going to get 3 times 4 because I circle the 4s, so the 4 jumps out, it joins the 3 that's already out there, it joins the 9 that's already out there. Okay, and I don't want to subtract first. Make sure you do order of operations. So you're going to go 3 times 4 is 12. Then minus 9 gets you a 3. Okay, so let me show you the entire page. So show you the entire page, the whole problem. You're going to compare the left side to the right side. You got 3 on the left, you got 3 on the right. These guys match. That's exactly what I'm looking for, so we are happy. So your answer for this problem can be officially declared 125. Okay, all right, next problem. All right, let's go back to fit, or best fit rather, on the screen. Okay, so this one, they're not showing you a radical. They're showing you 5x minus 1 to the 1/3 power. So this is where you got to remember what the fraction as a power does to the 5x minus 1. Okay, and we haven't had this in a while, so you might have forgotten about it. So hopefully you didn't forget everything. And when I write what this problem is going to become, then you're going to be like, oh, okay, I get it. Okay, so we got the 3 on the outside. And then the 1/3 power. Okay, the 1 on the top tells me I have a single 5x minus 1. The 3 on the bottom tells me what kind of radical I'm going to put the single 5x minus 1 into. Okay, so you got to remember that. Top of the fraction tells you how many you have. The bottom of the fraction tells you what kind of radical it is. So I have a 3rd root radical, or you can just say cube root. So I'll put a 3 in that radical space, right? That little check mark linking space on the outside. Okay. Then I'm going to put a single 5x minus 1 on the inside. And then minus 6, and then equals 0. So now I just made problem number 3 look exactly like problem 1 and 2 that we just finished. Okay, then we're going to continue our business. We're going to do exactly the same thing that we did in 1 and 2. We're going to get rid of the things so that we can isolate the radical. Okay, so we got 3 on the outside. Cube root of 5x minus 1. Ooh, forgot to draw the line because these guys are going to be combining. Okay, so n equals, then 6 on the other side because the negative 6 and positive 6 cancel. Okay, then I'm going to divide by 3 on both sides so I can get rid of that. So divide by 3, divide by 3, okay, and I get left side equals cube root of 5x minus 1 equals 2. Okay, then I'm going to get rid of the radical by exponentiating, and I'm going to use a power of 3 to get rid of a cube root, right? Whatever your radical is, you're going to use the exact same number to get rid of that radical. So since it's a cube root, I'm going to use the number 3 to make it go away. So left side becomes 5x minus 1. Right side becomes 2 times 2 times 2, which is 8. Okay. Then I'm going to continue solving for x. So let me page expand. So add 1 both sides. Then I get 5x equals 9. Then I divide by 5. And my answer doesn't look like it's going to be very pretty this time around. But There's no rule that says your answers always have to be nice looking numbers. So your answer is going to be 9 over 5. Okay, is this answer going to work? Well, we'll see. That's why we do checking of the answers, because we want to see if these sometimes weird numbers that we arrive at, we're going to see if it actually works. So let's check out x equals 9 over 5. Okay. All right, so when you check your answers, I've always said plug into your original problem. Okay, so this is where I'm going to kind of retreat a little bit, and I'm going to say, well, you can plug into your original problem if you want, but if you want to rewrite it, if you want to plug it into the radical form of the equation of the original problem, then you're free to do that. So when I say the radical form, I'm talking about the one that we wrote on the very first line of this problem, yeah, with the cube root, yeah, because it's probably a little easier for you guys to check the answer because you're more familiar with how we deal with radicals compared to when you want to just leave it as exponent form. So yeah, you're free to just plug it into your radical form. So if you're wondering what is radical form, it's this. Okay, so I put the 3 on the outside, it's a cube root. Then I go 5 times 9 over 5 minus 1 minus 6 and equals maybe 0. Okay, so this is radical form. So you see that radical symbol in there. All right, so like I said, I usually tell you guys plug into your original problem, but this is fine. Okay, you're allowed to plug it into the radical form of the original problem, and that's perfectly fine. No harm done in that sense. Okay, so my right side is already fully simplified. My target is a 0, so let's just play with the numbers on the left side. Okay, so you got the 3 times the cube root of, and then you're going to go 5 times 9/5. So that's going to make 45 over 5. And then minus 1, and then minus 6. Okay, then you're going to keep on simplifying. You got 3 times cube root of 9 minus 1, right? Because 45 divided by 5 is 9. And then minus 1, and then minus 6 on the outside. Okay, so let's keep on playing with the numbers. 3 times cube root of 8 minus 6. And then you want to break apart that 8 into a bunch of smaller numbers that hopefully you have 3 matching numbers. Then you can circle it. So 3 on the outside, cube root. Let's break apart that 8, a number that we've been breaking up a lot recently. So 8 is known as 2 times 2 times 2. And then minus 6 on the outside. So I get my red pen out, and I'm going to circle things that match, and I got 3 3s that match. So that, when I say 3 3s, 3 2s that match. Sorry, I said the wrong number. 3 2s that match. So the 2 is going to jump outside. It's going to join the 3 that's already out there. So you got 3 times 2 minus 6. Okay? So do your multiplication first. So that's going to make a 6 minus 6, and that's going to make a 0. So compare left side to right side. And what is your conclusion? They match. So we are happy. So happy means that we can officially submit the answer 9/5 for this problem. So 9/5 is our answer. We're good to go. That answer works. All right. And let's go to our next problem. I think it's the last one, if I'm not mistaken. Okay, so once again, it's written in exponent form, so you're free to make this into radical form in your very first step. So we're going to go 4 minus 4th root radical of 7 minus x, and then equals 0. Okay, so this one's going to be a little bit different, okay, because usually my first step was to get rid of the 4, yeah? So this time, though, I'm going to move around the radical, because right now the radical is negative, and I don't like that. I don't like when my radical is negative, so I want to get rid of that negative sign. So the best way to do it is not to move the 4, because there's nothing wrong with the 4. The one thing that's wrong is this guy is a negative, so I'm going to add 4th root radical of 7 minus x to both sides. And that's going to cause everybody to become positive. Oops, I almost forgot to write the 4 there. And that's going to make everybody positive, which is going to make all my numbers all around a lot nicer, a lot easier to manage. Okay? I mean, you could subtract 4 if you want and leave this radical negative. You can still do your problem, but knowing you guys, right, I've been in this business for a long time, students don't typically like negative numbers or negative anything. Yeah, and then when you see a negative radical, you can be like, whoa, that's even like my worst nightmare. So Yeah, you probably want to get rid of that negative first. Okay, so left side is 4. Right side is 4th root radical of 7 minus x. Okay, and now you're going to see that it's the same kind of steps that we just did in the previous kind of problems. We're going to exponentiate both sides. And to get rid of that 4th root radical, we're going to do power of 4 on both sides. And I think we've come across 4 to the 4th power already earlier on a previous problem, and we realized that it's 256. So we're going to use previous knowledge and experience to get us through that 4 to the 4th power pretty quickly. Right side is going to become 7 minus x. Okay. All right, so let's get rid of that 7. So subtract 7 on both sides. And we get, let me page expand. Ooh, I forgot to put it back to best fit. So let me change the mode of the view. Okay. And scroll down. All right, so what do we got? Left side is 249. Right side is negative x. So we got to get rid of that negative now, right? So let's get rid of that negative. And some teachers, they make you go divide by -1. I'm just going to make you divide by a negative because that's basically what you want to get rid of, right? You want to get rid of the negative sign. So I'm going to divide both sides by negative. Then it's going to cause these negatives to cancel. And my final answer is going to be x equals -249. Okay, and then I'm going to check my answer like you're supposed to do. So we're going to check x equals -249. So let's plug that in. Okay, so we got 4 minus the 4th root radical of 7 minus x. So 7 minus, and I'm going to plug in -249. So I get 2 negatives in a row. Please, please, please be careful because a lot of kids, when you guys plug in that -249, you put only one negative sign. So don't forget there's a second one. First negative is from the original problem. Second negative is from the answer we got, -249. Okay, so let's start playing with the numbers. So we're going to get 4 minus 4th root radical of 7. Oops, forgot to draw my wall because my target is 0. So 7 plus 249 because the negative turns into plus. Then I continue my route, so 4 minus 4th root radical of 256. Then I got to break apart 256 into smaller numbers, and, well, deja vu. We've done this already. We've broken up 256 before. Yeah, I think that was in problem number 1, so this should not be a big deal. So 256 is going to be known as 4 times 4 times 4 times 4. Then I get my red pen out, circle the things that match. Then the circled set of 4s jump out as 4, so you basically have 4 minus 4, which makes 0. So when I compare left side to right side, they match, and we're happy. So my answer, -249, is legit and good to go. Okay? Alright, so I hope this lesson wasn't too bad. And if not, you can always ask questions in class. I will see you later, and good luck on the assignment. Bye-bye.